Hi, everybody. Welcome to our webinar, and thank you for joining us today for the topic Beyond Kubernetes Security 101, Multi-Platform Governance and Policy Enforcement in AWS. My name is Randy, and I will be your moderator for today's session. I do have some housekeeping items I want to share with you. This session is being recorded and will be sent out shortly after we conclude. And then we do want to make this as interactive as possible. So please feel free to put your questions in the chat and we will address them in the Q&A session at the end, or if it becomes available during the presentation time. I do want to introduce you to our panelists and have them do a brief introduction for you. We have Christian and Boris. Christian, I'll let you kick it off.
Hi, thanks for joining or maybe watching the video later, but I'm Christian Posta, Global Field CTO at Solo.io, where we work on cloud networking and API gateways. And I've been in this space for quite a long time now. Before Solo, I was at Red Hat, worked on Kubernetes and containers from the very beginning there. And even farther back, my background was in messaging and integration and that kind of stuff. So good to be here and to speak about some of the stuff that we're doing in AWS.
Awesome, great. Boris, I'll hand it over to you.
Yeah, sure. Hi, everybody. My name is Boris Kirchiev, and I'm a solutions architect with Nirmata. My cloud native journey is varied in a fun twist of events. I met Christian as a competitor back in the day, but thankfully that has not prevented us from being able to have good, interesting conversations as we've gone through, kind of time. The hope today is to chat with you all about, what does it mean to govern your cloud and how you can do that with some of the things that Nirmata does, and obviously the things that Solo does, and hopefully how you can use those strategies and those tools to better your journey.
Awesome. Thanks, Boris. I'll hand it over to you to get hopped right in to the content.
Yeah. All right, let's get started. Let me share. So feel free to ask questions as we kind of go through this. Somebody will be tracking the Q&A session or the Q&A box. The idea here is to have a conversation about these topics, demo some useful tools and useful concepts to everybody. At the end, you'll get a link with kind of the repository of some of the things that I'm going to show you, and I believe everything that Christian is showing is available in one form or another through Solo. But at the end of the day, we're going to focus specifically on AWS and more focused even on ECS and how can you extend some of these kind of generally more Kubernetes native or at least components that are thought of as Kubernetes native beyond their initial use case, and making sure that it's not a square peg round hole type of problem, but rather an actually properly integrated solutions that can make your life actually easier. We kind of already covered this, but Christian is a globe-trotting face of Solo. I'm just a peon here at Nirmata, but hopefully the knowledge is still there. So I just kind of wanted to start here. This is something that the CNCF put out a couple of years ago, but because of what we're discussing today, and especially focusing on, hey, how do I do service mesh, how do I do ambient in the beyond Kubernetes, how do I tie all of my resources together into my mesh, it's important to note that misconfiguring these things, misconfiguring components regardless of where they live and who deploys them, who controls them, who runs them, it costs money when you misconfigure something. It costs money whenever your components are not communicating the way they're designed to or need to. It costs money whenever they're not, security ends up being a day two problem that we're going to solve at some point rather than something that's baked in from the ground up. And the CNCF actually did run this and produced an actual cost per defect, right? And this is the findings here are all based around a single cluster. Obviously, none of us are running a single cluster. All of us are running some form of, best practices here. So you can see that scaling up, this becomes a very, very expensive proposition. So making sure that you have the right guardrails, that you have the right, gates to pass through before you get to production is important. We will be touching on kind of the concept of zero trust. So I just wanted to throw out the general pillars of what zero trust is. We don't have to, the idea here is to not dive super deep on everything zero trust, but at the end of the day, you need to assume that you're compromised, right? Like the idea that, oh, my perimeter security is going to take care of me, that my existing concepts and guardrails are going to do their job, just kind of goes out the window immediately. Microsegmentation becomes a very, very important thing. This is great in Kubernetes, but like, how do we start, talking about microsegmentation in other orchestration engines or other kind of infrastructure pieces? How do I deliver least privilege and making sure that both the people accessing the systems have least privileges, but also how to make sure that the components themselves, when communicating with each other, have omnidirectional communication patterns as an example. And then being able to obviously have kind of the audit trail, the logging, the monitoring, the metrics, all of these pieces that we all love seeing the rainbow charts of, and don't really pay too much mind until there is a problem or until somebody does ask a question and we have to go, hey, yeah, no, look right there in order to see what's truly going on. So with that, what am I going to kind of walk you through over the next few minutes is a few demos. And the few demos are everything that you're going to see is available on GitHub and accessible. You'll get a link, or Randy can drop a link in chat now, but ultimately at the end of the webinar, you'll also get a link to all of this. But the important kind of story or journey that I hope everybody takes away is it is not good enough to be able to protect just your existing infrastructure or to protect and become aware of a problem once that problem hits your kind of infrastructure or is in production, if you will. It is much more powerful and useful to both your end users, but also to your operators and platform engineers to be able to identify, hey, there is a problem as soon as my developer submitted a PR, right? I can give them actionable feedback of like, hey, this is where you're failing. This is what the problem is. Please try to fix this. The other piece is, there's going to be a few tech previews that are not going to be truly, I should say maybe not tech previews, but tech teasers around like, well, how do I make sure that my developer who has access to, let's say, the AWS CLI is also protected and is not allowed to submit certain requests without any guardrails. And then, that same guardrail that I am now using in my repository, in my PRs, in my CI/CD pipeline, I'm able to use that same exact guardrail to protect the command line. And then, just a few example architectures of how you can use those policies and those guardrails to look at your existing AWS inventory and get a report back of like, hey, here's the problems that you have, as well as, do kind of a in cluster or in account governance of resources that are coming in and out. I see questions, Randy. If there is something that looks very specific, or Christian, feel free to interrupt me. I'm going to, for right now, keep plugging away.
Awesome.
All right. So before I dive into the command line and everything else, let's just kind of look at what are we talking about here. The first use case is, as I said, like as a developer, I need an actionable feedback. Some of you may have heard of this as shift left security. I prefer the term shift down, mostly because shift left generally inundates your developer with a lot of noise and not a lot of actionable, noise ultimately. It does not give your developer a good way to remediate the problem or work with the report to actually create, at the end of the day, a fix for the problem that is being reported. So governance in repository that gives you, again, an actionable feedback becomes very, very important. So in the same repository that we're going to, everybody's going to get access to, I'm using GitHub, but this workflow is translatable to absolutely any, CI/CD pipeline. We have Jenkins plugins, we have GitLab integrations and examples. I'm just using GitHub because everybody's generally familiar with this. But there, you'll see there's a couple of actions here that are going to do certain things. I have an action that every time there is a code push to or in a PR opened, will run, and what it will do is utilize. Let me open it up. Yeah. It will utilize a tool that we have released and investing quite a lot of effort in called NCTL, or Nirmata control, which allows you to use your kernel policies, to use your the existing policy sets to scan your Terraform code, to scan your AWS, components that might live in repository. You can scan Ansible. You can scan absolutely any type of code in your repository with a kernel policy that you're already using in Kubernetes, right? So pretty simple here, but ultimately what you will get is that in a call, and I wish I could, I have to make it a little smaller, which is opposite of what I normally have to do, but to make it fit, I can get, I will scan the PR of all the code that has been pushed by my developer, and I can give them a specific, hey, this piece of your Terraform code is broken. You're trying to use public IP addresses. Bad, right? What we, is harder to show in the command line here is we also have remediation. So like we have actually a suggested remediation that the developer can click on and create a follow-up PR to their code with the fix for this particular problem, right? So getting this is, from a developer standpoint, much more valid and much more useful than, okay, well, I pushed something, it went to QA or sandbox or wherever it goes through before it gets to production. Maybe it got caught, maybe it didn't get caught. And now all of a sudden I have a resource with a public IP that shouldn't have had that. All right. The other piece is, well, how do I, check my existing catalog? How do I make sure that what's currently running in ECS is also protected? And I'm going to pull up here. This is a very standard. Oh no, that's the wrong one. Sorry. This is a workflow, right? Again, you can use Jenkins for this. You can use the GitHub action that is included in the sample repository. But using NCTL and using a few other things, you're able to go in and go into your account and create a passive scan report that will tell you, hey, based on, let me get back in here. I can show it. Sorry for all the clicking. I know it can get a little annoying. But based on all of the resources that you currently have running in AWS and all the ECS clusters and tasks and task definitions that you have, currently you have, the company has decided that all ECS containers need to have insights enabled. Right? I now have an actionable plan of like, hey, I'm failing here. Again, you can click and get to the actual resource, AWS, ARN, everything else that will take you to it. Furthermore, and again, I'm kind of flying through this, but this gives you a more passive view, big picture. This is what's happening. This is how it looks right now. The active governance, which is kind of something that lives inside your AWS account, leverages Lambda. And this piece is something that, again, this is more of a tech teaser. Hopefully, if you guys are at KubeCon, swing by and let's chat, because we're going to announce some really fun things and very interesting things around this specific piece. But using Lambda, you can actually intercept and interface with the end user's request and say, hey, this is bad, this is good, this is where the request is failing, this is where the request is succeeding. I'm providing all the necessary bits that you need to build the Lambda function in here and the policies as an example. But what it will do for you is that now you can push all that data in a central repository, along with all of the other data that you saw so far. And I'm going to go to Nirmata Policy Manager, which is our kind of all-encompassing infrastructure governance and security platform. But I can get all of this data that you're seeing so far published into a central spot where I can give my developers view of all of this. I can give my managers, my VPs, whatever, views of how am I doing? How is my infrastructure doing? Are we adhering to the ECS best practices? Because ECS does publish a best practices list. And here you can actually start seeing, hey, specific clusters or specific repositories are failing. Here's the specific files that are failing, the specific policies that are failing, or the specific files within those policies, as well as from my Lambda function, I can get which cluster ARN is failing, which specific task is failing, that type of detail. This is, from a compliance standpoint, very, very, very powerful, right? Like I can immediately see how is my ECS infrastructure doing, how is my how are my repositories doing, useful information overall. And the final piece is, and again, this is tech teaser because there's going to be a bigger announcement at KubeCon. But how do I protect the command line? How do I make sure that my developers who are given command line access don't accidentally blow up a cluster, create a task that is, has a public IP, doesn't have container insights? Well, now we have a piece that connects through to NPM that sits in between your AWS calls and your developer, and can do everything from ECS task definition supply chain security by verifying your images through Signer. So making sure that you have all the right SBOMs, that it's passing the right provenance, that is signed by the people that, the signage that it needs to have in order for the image to be allowed. Excuse me. All exists before, again, being admitted to AWS for actually ECS to execute. So what does that look like, right? Hopefully everybody can see my command line. But now I have our cloud controller running, so I can do, let me list clusters. This is a pretty innocuous, pretty normal action that a developer will take. Not a malicious, nothing could essentially be maliciously or cause any maliciousness, I should say. So let's say that I want to create a cluster, right? Well, hold on. Output aside, we're working on the output. That's why I said it's a tech teaser at the moment. This will be a lot more cleaned up. But the same policy that I used in my pipeline, the same policy that I'm using in my Lambda function to check, hey, am I using container insights? In this particular case, I'm also checking, hey, are you tagging this properly? So we know what teams are using this, for what function they're using this, etc. No, right? I'm currently failing this particular test. So if I go, okay, let's go ahead and pass in tags. It was like, well. Again, you're not passing the full set of requirements. Please, add in insights. In this case, I'm probably, I'm getting all clear. Now my cluster can pass. But the important takeaway from this is that, again, the developer was forced to walk through, hey, what is wrong? What is the actionable item that I have in order to pass my company's compliance, my company's best practices, my company's needs, before I'm allowed to actually spend money, create infrastructure that may or may not conform to what we're looking for. And again, when you step back from all of this, this is very, very important when, again, we're talking about zero trust and we're talking about the pillars, right? Like, how do I do verification? How do I create microsegmentation? How do I ensure least privilege? Becomes very, very, very powerful when I have tools that I can integrate across my entire pipeline, across my entire life cycle. And with that said, just kind of in conclusion, by combining all of these pieces, right, a developer is given more control and more understanding of where they need to change, but also, as importantly, the operators are able to now run the infrastructure with the same set of policies that they already use out for the cloud and for whatever it may be, and apply it across all of the life cycle of their end users, rather than, well, I'm going to just deal with network, or I'm just going to have some policy that will apply to my Kubernetes clusters, that type of kind of thing. We now give you a full holistic approach to solving the problem of governance across the board. And I think from here, I'm about to hand it off to Christian.
Awesome, thank you. Hera, how about let me share my screen. Let me run the slides, and then I'll also sprinkle in a few demos here. Let's see, share screen. I'm gonna share my whole screen because I'll be bouncing back and forth. You all let me know if the text is not visible, or if the font, whatever sizes, could be increased. Okay, so we saw in Boris's section on how to build policies to control what developers are able to do and kind of paint those golden paths. Like if you think about it from a platform engineering standpoint, paint those golden paths so that they can kind of self-service and they can kind of kick off builds, deployments, and run their applications and services in AWS across various types of infrastructure. But once things are running, we need to secure the traffic, allow the traffic, write policies about how traffic is allowed to connect, secure that traffic, observe that traffic. And in AWS, whether you're on ECS or EKS or EC2 or wherever, there are a lot of good foundational networking controls at the VPC layer. And as you start to move up into layer 4 and layer 7, it becomes less opinionated, it becomes less out of the box. I think for a long time, AWS recommended if you're going to be looking to apply security and traffic routing policies at layer 7, then use something like a service mesh, but app mesh is now deprecated. So AWS is also saying, start with basics, use things like Lattice, use things like, if you're an ECS, use things like Service Connect to get basic layer 7 capability. But then if you need something beyond that, look at a service mesh like Istio. Now that tends to be a little bit more advanced of a use case, but there is real problems that need to be solved there, typically around compliance and governance. Things like enforcing MTLS, having encryption between our services. We see a lot of organizations that are running workloads on premises and in a public cloud in AWS. And they are looking at building connectivity policies about how traffic should be handled, when traffic should be denied, all the way down to the granularity of, well, this token and these headers need to be there when calling this path on an API, et cetera. And having something at layer 7 to do this and something powerful and configurable enough to do this is required to meet their compliance goals. Now, if you're thinking like, all right, why am I talking about Istio? And because we're looking beyond Kubernetes in this webinar. We're looking at workload types like EC2, like ECS, like Boris mentioned and demoed. Istio doesn't really run that well in ECS and other environments, but does bring a lot of value for what it does. And if we take a little bit closer look at how it works and what's happening in the Istio project, then we can start to alleviate some of those concerns of running a service mesh with its full capabilities in other compute environments. So Istio, like other service meshes, like AppMesh, uses a sidecar proxy that is based on Envoy. And Envoy is an extremely powerful layer 7 proxy. And what Istio does, or what these other service meshes do, is deploy this proxy alongside each application. In Kubernetes, this would be within the same pod as the application. And then from there, you get these capabilities. The proxy will automatically do encryption, automatically can handle layer 7 and layer 7 policies, grab telemetry, and so on. The challenge with taking a proxy like Envoy, which does a lot of stuff, is that it can be difficult to configure. It can be difficult to get it running in various environments. So Istio has been built sort of Kubernetes first. It was never the intention to be only, but a lot of assumptions have been made about bootstrapping Envoy and running Envoy and doing that in Kubernetes. So bringing it out into other environments can have some hurdles. In the Istio project and at Solo, we've been heavily involved in this innovation. What we've been working on is a sidecar-less approach to Istio specifically. And the way we do this is we obviously remove the sidecar, remove the this proxy that's running with the applications, and we kind of carve up some of its capabilities and separate it out so that if you adopt a service mesh, you can incrementally adopt it. The first step should be easy. Getting, for example, MTLS, that's kind of the #1 use case of a service mesh. Getting to that step should be easy. And then if you want to further adopt the layer 7 capabilities, then that should be composable. And so with Istio, we introduced a data plane mode called Istio Ambient Mode that follows this paradigm of removing the sidecar where appropriate, where we can, and introducing a layered topology for our data plane so that we can onboard things much easier. And doing this, for example, in a Kubernetes world, simplifies onboarding. You don't have to restart applications and inject sidecars and do all that stuff. It lowers the cost of adoption because we're running far fewer of these layer 7 proxies, and increases performance. If we don't need layer 7, we can just use MTLS without taking the cost of parsing L7. Becomes more secure because we're separated from the sidecar and so on. But for extending out into other infrastructure, it's the simplification of the data plane into two different. So we want the first step to be simple, and so what we've done is we've built this agent that runs either as a daemon. It can run in a sidecar if we need to, but it runs as a daemon on a node. That its only responsibility is when a connection gets opened is to apply certificates and make it an MTLS connection. That's its only responsibility. And then so we start with that as the foundation. We call this the Z tunnel or zero trust tunnel. And then we can layer in the layer 7 capabilities with Envoy or whatever. In a data plane layer we call the waypoint proxy layer. So by example, if we have a couple of hosts running containers, we can run a Z tunnel daemon. And like I said, when an application tries to open a connection to the outside world, the Z tunnel will intercept this and apply MTLS to it. So that as traffic's leaving that pod or leaving that application, it has encryption, it has MTLS. Those MTLS certificates can be backed by SPIFFE and a workload or a workload identity spec that can cover both AWS and on-prem and allow you to write policies that are consistent and uniform across those environments. And the traffic, when it gets to the other side, the Z tunnel will do the reverse. It'll say, okay, this has to be an MTLS connection, otherwise it won't accept it, and then pass it off to the application. So this does all layer 4, just MTLS, no layer 7. If we want layer 7, then what we can do is deploy what we're called the waypoint proxies. Waypoint proxies are Envoy proxies. They can be deployed per namespace or per application, but they don't have to run as sidecars. So you can think of this as lightweight tenant gateways or micro gateways that get deployed, and then Istio handles routing the traffic from the Z tunnels to these layer 7 proxies if layer 7 capability is needed. Otherwise, it gets bypassed, and you see a significant performance increase. And you actually get a performance increase in this model over the sidecars because you're not processing layer 7 on both sides of the client and server connection. Now, if you want to scale these waypoint proxies, you can do that in a way that better fits the traffic coming into the services versus just scaling up all the sidecars in a service. So if your traffic is going to application B and you need 10 pods to handle the traffic for application B, but you really only need 2 or 3 Envoy proxies to handle that load, and it doesn't make sense to also have 10 sidecars of Envoy proxies running, right? That'll be just complete overkill, and you can't size the resources appropriately. If you want to learn more, we've written a book on this. The Istio website does a good job. At Solo, we've got a lot of hands-on labs and stuff that you can go into to dig in a little bit more. I'm going to show a demo though real quick. So here, if you can see this, hopefully, Boris or Randy, let me know if this is not very visible. But in this,
a little bit.
Sorry,
like if you can blow it up like
a little bit more.
I think you'll be yeah there.
Okay. Yeah. So in this Kubernetes cluster, it's running on AWS. We do have Istio installed. It is running in ambient mode. We see the zTunnel daemon that I mentioned. zTunnel handles the MTLS. If I come back here to my default, I see I have 3 workloads running here, a sleep service that we'll use as a client. We have a HTTP bin that just returns or allows you to interact with the HTTP server, and then a simple echo service. You can see that there are no sidecars here, but these are in the service mesh. If I come back here and look at the default namespace, I've labeled my namespace with Istio's data plane mode equal to ambient. And because I've done that, when I am in the an application here, if I do curl echo.default, I'll see a response, and this is coming from a pod here in Kubernetes at the moment. If I do curl http bin.default headers, we'll see traffic go to the headers app. But you'll notice, if I come back here again, no sidecars. But if I come to my Kiali application, let's refresh it just in case, which is the default dashboard for kind of understanding what's happening in the cluster and traffic, and come here, we'll see that Istio is running, that telemetry is being captured about traffic, and actually it's not showing. If I come in here and turn on the security badges, that the traffic flowing between these services, if I click on one of these icons, is secured using MTLS, right? And you can see the spiffy SVID workload identity names here. So traffic is encrypted. It is flowing through the service mesh. That's all good, but this is just Kubernetes, right? So what we want to do is take the same foundation and extend that out to other workload environments, other infrastructure, like ECS. So for example, running on ECS, where we have tasks that run on hosts or potentially run in Fargate, I'll talk about that in a second, we can use the zTunnel to accomplish the same thing for the service mesh, which is basically have this extremely lightweight, highly focused daemon or process that its only job is to enable MTLS. And you deploy this with your applications, and you can then get the power of the service mesh because the zTunnel handles connecting everything up. Now, if you're, again, trying to go through, now in this case, we use Fargate. We deploy the zTunnel with a task in Fargate, in this case, as a sidecar. So as a second container in the Fargate task, in the ECS task. And we can also bounce through waypoint proxies to enable layer 7, things like timeouts, request level timeouts, and load balancing and retries, circuit breaking, that kind of stuff between our applications. And so let me show a quick demo of that. So why don't we come to, I have my AWS console here. I will make this bigger as well. If we look in our ECS dashboard, we'll see I have a cluster here, and I'm running a few tasks, a few different services, a shell client also with the zTunnel, and an echo service also with the zTunnel. So with the zTunnel deployed here, now I can connect into the service mesh. I can connect to workloads that are running on ECS. I can also connect to workloads that are running, in this case, in Kubernetes. And so to perform that demo, let's go here, and we're going to exec into our shell task. Give that a second. Now, if I do a curl of echo.default, we should see the traffic. First of all, we should see it succeed, but we should see the traffic go from our ECS task to a service that's running on Kubernetes. This is the same Echo pod that is running in Kubernetes. If I do curl hb-bin, default 8080, go to headers, we should see the same thing, the response. And so now this traffic is going from the ECS task through ztunnel over MTLS to these services in the mesh wherever they might live. If I wanted to call a service that's running in ECS, because we saw from the ECS dashboard here that we have an Echo ztunnel that's running in ECS, I can do curl. We'll do the Echo ztunnel.ecs.local on port 8080, and we should see a response. Now it's coming from an Echo service that is running on ECS. And again, the traffic is over MTLS. Now, if we wanted to, we'll come out here for a second. If we wanted to add layer 7 capabilities, then what we can do is apply Istio resources. We'll need to deploy a waypoint proxy, but we can apply Istio resources to do things like governance and authorization policies about what traffic is allowed to communicate with which services. In this case, let's write an Istio authorization policy that denies traffic coming from, well, you can only call HTTP-bin if you live in the default namespace or in that particular zone. And to do that, we'll deploy this. So if I try to call HTTP-bin from ECS, which, let's try that again. If I try to call from ECS, then it should fail, and it does. I should still be able to call default, and that still works, but HTTP-bin I cannot call because we've specified a policy, a runtime policy about traffic going from the ECS to the HTTP-bin. Now, if we wanted to implement some layer 7 policies, we need to deploy a waypoint proxy, and from there we can add a policy that says, in this case, we're going to delay traffic from ECS or from somewhere to a HTTP-bin. If we let's see, let's come here. Let's go ahead and deploy it. All right, so we deployed it. If we call it from sleep, from our sleep app in Kubernetes, we'll see that we do indeed get the delay. Right, we got about 5 seconds delay when we called it from Kubernetes. Now let's try to call it from ECS. So to do that, let's get rid of that authorization policy that denies traffic. Delete. Let's delete that so that we can call it. And then now if we call HTTP-bin from here, we should see that it gets delayed by 5 seconds. Here we go. 1, 2, 3, 4, 5. And we should see a response. Okay. So now we get layer 7 policies for traffic in ECS as well. So what we've done, like I said, is we've simplified Istio's data plane or made it more composable so that we can take pieces and run it more reliably and easier in these different infrastructures like ECS, as well as Lambda. So we also have this working in Lambda so that Lambdas can connect into the service mesh as well over ztunnel, getting MTLS, getting configurable layer 7 behaviors, networking policies, and so on that can be written to spiffy workload IDs. So I showed the demo. I think we will wrap up here. And so at Solo, we've been working on this technology for quite a long time. We're the founders of Istio, the leaders of Istio. We're the leading contributors to Istio, and we are driving the innovation around ambient mesh forward. It is ambient mesh in the Istio community is ready for production usage. Once you get past, I'll say that with a caveat, for single cluster deployments. Once you get past that and you need things more advanced, connecting to VMs, connecting to ECS, connecting across multiple clusters, multiple networks, that's where Solo comes into the picture, and we can help with that. So I'll end my section there. I know, Boris, if we want to do some wrap up.
Actually, I had some questions more from for you from the field. How do customers deal with generating the virtual services, generating, kind of the Istio resources that are necessary to create all the governance that ultimately you showcase here? What are you seeing? How are people solving that? Are you, give me your thoughts around that.
Definitely. So in general, what I would recommend is that people don't try to write Istio resources themselves. Istio has rebased, or has implemented, and has had this for a while actually, support for the Gateway API. So teams that, especially platform teams that are looking to build the YAML configurations and stuff that drive Istio, they can standardize on Gateway API. They can, build. Typically, what we see is people building automation, building templating engines, building templating systems for their platforms that then drive that behavior, because we don't really want the developers building and writing this by hand. So using various forms of automation to build that is how most people are doing it.
Yeah, no, that's great, because kind of the main thing that was running through my head is obviously tying in Kubernetes mutation capabilities from at the very least from the cluster side, and just kind of giving your platform engineers a way to maybe create applications with certain labels that then get automatic destination rules, whatever, generated for them based on kind of input data from the developer or from the platform engineer.
Exactly.
Yeah.
Awesome. Do we want to transition into Q&A? If anyone has not had the opportunity to put questions in the chat, now's the time to go ahead. I'll make sure to address as many questions as possible with the allotted amount of time we have, which is about 11 minutes right now. I know there were some questions while everyone gets their questions in the Q&A. I think this question is for you, Christian. Is Istio ambient mode ready for production? That was a short question for you.
Yes. So like I was saying, in an open source project, we've had, so Istio has, unfortunately, odd naming for the features and the status of those features. So for example, a lot of what is being used in production today with Istio and is hardened and is trusted and so on, unfortunately has the beta status tag to it in Istio. But so Istio Ambient has graduated to beta as of May 2024. And there are people using it in production. But I gave the caveat that it's mostly single cluster deployments right now. We have customers at Solo that are running in production, and we have some of the multi-cluster capabilities built out. VMs, we support VMs, we support ECS and Lambda as I was showing here. So I would say yes, it's production ready. if you need more advanced capabilities, then come to Solo, come to the people who are building it anyway, and we can help.
Awesome. I think this is a general question, so this could be for you both. I know this is AWS focused, but could this be cloud agnostic?
100%. Yeah.
No, everything that at the very least there, I think everything that both Christian and I kind of showed is we're targeting AWS because generally speaking, a lot of I believe our customers are in AWS, but the technology itself is 100% cloud agnostic. Everything that is in the repo and in the demos that I showed is actually based around parsing JSON and JSON calls. So like I'm actually working on a Azure demo very similar to what we're doing in AWS. So yeah, I would 100% say that this is not a cloud specific targeting. We're just kind of had to pick something, right? At the end of the day.
Definitely. I'll reinforce that from our side as well. Istio, so all the stuff that we do here at Solo, from our Kubernetes API gateway to Istio and Service Mesh, all that stuff is cloud agnostic. Moreover, I would say very on-prem friendly. Most of our organizations are hybrid, right? On-prem and some public cloud, sometimes 2 public clouds. And our solutions are intended to help bridge that gap in those environments.
That's great. Christian, this one is also for you. How much overhead is saved when using Istio ambient mode?
So we do have some good data on that. I'll try to post that in the chat, the links in a second. But we've seen at least 90% overhead savings in terms of memory and CPU. And some of our very, very, very large customers, they run on AWS or they run on some big cloud, hundreds of clusters. And when you run at scale, the sidecar, resourcing for the sidecar tends to add up quite a bit. Ends up being probably around 25% of overall compute, which is, you do get a lot of value for it. But if we can chip away at that, that's real money. So we've seen at least 90% in most cases.
That's awesome. And then this question is kind of for you both. Is there anything we can look forward to in the future, aka KubeCon, any events coming up, announcement wise? Is there anything you could hint or give us future knowledge of?
Yeah, I mean, for sure, at KubeCon, a lot of the things that I was specifically talking to are currently just a solution that I've put together that we're going to have some exciting announcements around, and what you can do at an actual proper enterprise scale and grade. Outside of that, I believe Christian and I are talking about potentially doing the kind of this talk and some of the demos live in booth. So I think we'll both be more than happy to chat with anybody and everybody that's interested in all of this.
Definitely. I don't want to get ahead of our marketing team, so I can't reveal any things that we're going to announce. But definitely, we'll have a very good presence at KubeCon. I think at Solo we have 8 talks accepted there into the main conference. I'll be speaking specifically on what we've learned over the last 7 years of building Istio and building Service Mesh. Me and Louis Ryan are speaking at doing that session. But yeah, stay tuned because we do have some good announcements coming.
Awesome. Looks like that's our last question. So presenters, do you have any final thoughts that you would like to share with the attendees today before we wrap up?
I think ultimately just try out what we have done out there for yourself, and feel free to hit either me or Christian up with any questions that you have. At the end of the day, we're both trying to solve the problem of how do we make sure that the operators and platform engineers and developers are able to have a more coherent experience in cloud native world. I don't know that anybody has ever, in recent memory anyway, gone to the cloud native landscape, but now it's entirely unnavigatable. So yeah, anything to make your life a little bit easier is, generally speaking, always welcome.
Awesome. What about you,
Yeah.
Christian?
Yeah, no, I just appreciate anybody, coming by, watching, joining the webinar. There's still a lot of innovation happening in this space, and just check out what we've shown. There's already a lot of stuff that we've shown. So, and reach out with questions afterwards if you have any questions.
Thanks, Boris. Thanks, Christian. I want to thank everybody for joining today's session. We really appreciate you taking the time out of your day. A special thanks also goes out to our wonderful panelists. Thank you for all of your insight and knowledge. Once again, this session will be sent out shortly after, so be on the lookout for that. And we hope you all have a great rest of your day. So thanks, everyone.
Thank you.
Thanks, guys.